The Krebs Cycle. The Krebs cycle is an 8-step process that takes place after glycolysis. This process takes place in the matrix of the mitochondria and eukaryotic cells. Energy is produced in the form of NADH, FADH2 and GTP. The pyruvate produced in an earlier stage of glycolysis is oxidized into acetyl coenzyme A to be used in the first step. During step 1, acetyl-CoA and oxaloacetate join together via condensation reaction to form citrate. This reaction is catalyzed by citrate synthase. In a two-step reaction, citrate is dehydrated to cis-acetate, removing a molecule of water and then rehydrated, adding a water molecule to form isocitrate using the enzyme acetonase. Catalyzed by isocitrate dehydrogenase, isocitrate is dehydrogenated into oxalosuccinate. Oxalosuccinate is then decarboxylated to alpha-ketoglutarate, losing a carbon from the chain. During this, CO2 and one molecule of NADH is produced. Alpha-ketoglutarate dehydrogenase assists in the oxidation and decarboxylation of alpha-ketoglutarate. The loss of one carbon atom produces succinyl-CoA and releases a second molecule of NADH and one molecule of CO2. Succinyl-CoA is converted into succinate using succinyl-CoA synthase, and a molecule of GTP is produced that will later be converted into ATP. Succinate is dehydrogenated using succinate dehydrogenase to produce fumarate, during which two hydrogen atoms are released, reducing FAD to FADH2, which is used later in the electron transport chain. Before the final step can be completed, fumarate must be hydrated, along with the assistance from fumarase to produce L-malate. Closing the cycle, L-malate is dehydrogenated and the remaining hydrogen molecules transferred to the surrounding NAD+, forming NADH. Malate dehydrogenase assists in the production of the starting compound oxaloacetate from L-malate. This can then be recycled in the original condensation reaction, joining with acetyl-CoA. The cycle is now complete for one pyruvate molecule. This has produced 3 molecules of NADH, 1 molecule of FADH2, 1 molecule of ATP or GTP, and 2 molecules of CO2 as a waste product. 2 pyruvates are formed from 1 glucose molecule, meaning the cycle is repeated twice for each molecule, allowing for higher yields of energy.